Lesson 6-4. Prove triangles similar by SSS and SAS. So this is pretty similar to Chapter 4, but in a different way. By the end of today's lesson, you'll be able to successfully use the SSS and SAS similarity theorems. The SSS similarity theorem states that if the corresponding side lengths of two triangles are proportional, then the triangles are similar. So if we look at the three sets of corresponding sides, AB to RS, BC to ST, and CA to TR. Example 1 is either triangle DEF or triangle GHJ similar to triangle ABC. Well, I'm going to first compare triangle ABC and check to see if it's similar to triangle DEF by checking whether the ratios of the corresponding side lengths of these two triangles are equal to each other. So, first of all, I set up the corresponding side lengths. So AB corresponds with DE. Okay, we need to look at the letters here in the statement, and then not be fooled by the picture. So that's going to be 8/4, and then BC is 9, EF is 6, AC is 12, DF is 8. And if we simplify this, you see that the ratio here, 2:1, is not equal to 3:2. So triangle ABC and DEF are not similar. Now let's check the other two, triangle ABC, GHJ. So AB corresponds to GH. So 8 to 16, not 8 to 18, okay? If you have to look at the similarity statement, AB to GH. So 8 to 16, BC 9 to HJ 18, and then we have AC, and then GJ, which is 24. You can go ahead and simplify. As you can see that after simplifying, the ratios are all the same. So we can say triangle ABC is similar to triangle GHJ. Example 2. Find the value of x that makes triangle ABC similar to triangle DEF. So we can use side-side-side similarity theorem and check to see if the ratios of the corresponding side lengths of these two triangles are congruent. So we can do, okay, so AB corresponds to DE. Again, you got to check your similarity statement. Don't just go with the picture. X minus 3 for 20, we can set up a proportion, and I could do BC to EF, 4 to 10. And then I could set up another one, 4 to 10, AC. So AC is, okay, and DF is 2x plus 3. Let's solve both of them to see if we get the same thing. Okay, again, we can simplify. And then x minus 3 equals 8 by cross multiplying. X equals 11. Side angle side SAS similarity theorem states that if an angle of one triangle is congruent to an angle of a second triangle, and the side lengths of these sides, including these angles, are proportional, then the triangles are similar. So this means that if angle X is congruent to angle M, and that ZX to PM, the ratio of ZX to PM is equal to the ratio of XY to MN. So we have side, angle, side. Then these two triangles are similar. Okay, let's look at a real life example. Marco is drawing a design for a bird feeder. Can he construct the top so it's similar to the bottom using angle measure and the lengths shown? So if we look at the angle measure here, angle ABC is congruent to angle DEF. And we also see that AB to DE are corresponding sides, so 32 to 20. And the other one, BC to EF. There we go, 32 divided by 4 is 8. So yes, they do have the same ratios for the sides, and the included angle is equal. So by SAS, Marco can design this bird feeder with the given measurements. So I would like to be a little bit more detailed. This would be SAS similarity theorem. Okay, I would like to do a quick review of the triangle similarity postulate and theorems. So we have AA similarity postulate. All you need is two sets of angles, corresponding angles, to be congruent in order for two triangles to be similar. And for the SSS similarity theorem, you have to have three sets of corresponding sides with their ratios equal to each other. And when you look for the ratios, you need to make sure that you're looking at the similarity statement and that the sides are corresponding to each other. So AB to DE, BC to EF, AC to DF. And with SAS similarity theorem, as I shown just a couple of seconds ago, you need an included angle that's congruent to each other, and two sets of corresponding sides with their ratios equal to each other. Example 4. Tell what method you would use to show that the triangles are similar. So for this one, I need to look at the picture and analyze. It seems like angle R or angle QRS is congruent to angle SRT by by vertical angles congruence theorem. And let's look at the corresponding sides. We have QR to RS, and then we have PR to RT. So QR would be 9 to 12, 18 to 24. Okay, now double check. 9 divided by 3, and then 6. So their ratios are equal to each other. So, and we have side, angle, side. Similarity theorem. And for this one, we can do So this will be triangle JKL. And then we can do the little one, which is LKM. Okay, let's check. It seems like we have 3 sets of sides, so we can check their corresponding side lengths. And then JL to LM, KL to KM. So JK is 49/28, JL is 56/32, and KL is 28/16. So the ratio is 7:4, so corresponding side lengths are equal to each other. So by the side similarity theorem, you can prove these two triangles congruent.